So in the first video today, we looked at how speech sounds are represented in the mind of a speaker. And we had two principal insights here. First of all, we saw that speakers remember distinctive features, and then from those distinctive features, they must be somehow in a position to compute the full specifications. So they start with an underspecified form in their underlying representation in what they have stored in their long-term memory, and then by some mechanism they arrive at a surface form that is fully specified not only for distinctive features but also for non-distinctive features. So that is exactly where we're going to start this video. We're going to start with the question how these underspecified phonological objects can be actually realized, how they can be carried to a surface form or surface representation. So surface representations, of course, are context sensitive. The speaker of English knows that the sound per at the start of a stressed syllable will be pronounced with aspiration and elsewhere without. So they can supply that featural content, that non-distinctive feature, plus minus aspirated, can be filled in depending on the context with the knowledge that it is only at the start of stressed syllables that something is plus aspirated. Now, you might notice something new here in our notation. We have slanted brackets around the first per, and this is the abstract per that is stored in the speaker's mind. And the term we have for this, we call this a phoneme. And phonemes we indicate with slanted brackets. And this contrasts to something that we'll see later on introduced as an allophone. And allophones are written then in square brackets. So this is a distinction that we'll be exploring, of course, a little bit more as we go on. Now, the underlying representation, in contrast to the surface form, as we've already said, is only stored with underspecified feature bundles, and this now can be converted into the surface representation by simple context-sensitive rules. So, for example, to encode the fact that an English speaker knows to supply aspiration when at the start of a stressed syllable, we can write a rule like this. Per goes to plus aspirated when it is at the start of a syllable before a vowel that is plus stressed. Or in other words, per is aspirated before stressed vowels. Now let's turn to this concept of phonemes and allophones that I've just mentioned. So the underlying forms that are stored in a speaker's mind that make up underlying representations of word forms are called phonemes. And each of these phonemes can have one or more realizations depending on the context that it occurs in. So these various realizations of a phoneme we're going to call allophones. For example, the phoneme per in English has at least two allophones. Per with aspiration before stressed vowels and b without aspiration that occurs everywhere else. So let's look at another sound that has a lot of allophones in English. Let's look at the voiceless alveolar plosive t, as you find in words like top, tree, butter and stun. And if you speak the right dialect and if you pay attention, then you realize that in all these words, the t sound is produced slightly different. So I'm going to say them again in a particular style of speech, and you have a close listen. Top, tree, butter, stun. I'm going to say them in a slightly different accent. Top, tree, butter, stun. So in both cases, you'll have realized that there are some consistencies and some differences to how these sounds are realized. So we can draw a phonemic diagram, such as the one that we've drawn here, where at the top lives our phoneme, t, written in slanted brackets, remember, slanted brackets for what is stored in the mind. And then in our square brackets, which indicate a phonetic or surface representation, we have the various realizations. In the first word, top, we have an aspirated stop. So that is the t with a little superscript h here, and the context for that is written below, namely at the start of a syllable, if preceded by a vowel that is stressed, which we have indicated here by saying plus stress as a little annotation on the symbol V for vowel. Then the next one that we have is the pronunciation of T in the word tree. And the word tree, T, is actually affricated. It has a period of frication immediately before transitioning into the approximant. So this is indicated here by the affricate symbol that we've briefly brushed on at the end of week 2. And you will notice in the environment that I've indicated here, I've made a slight error. This R symbol should really be upside down, like so. Now, the next realization of the T sound, and one that depends on your dialect, and which is why I've said these words 3 times in 3 different accents, is you will have realized that in words such as butter, the T can in some dialects be realized as a glottal stop. For example, in estuary English, it will be pronounced butter. And in other dialects, for example, American English or Hiberno English, that is Irish English, it can be pronounced as a tap, as in butter. So the tap is indicated by this little symbol here, and the glottal stop by this question mark-like symbol here. And the environment for this is between 2 vowels, the second one of which must not be stressed, indicated here by a subscript minus stress in between 2 vowels. And then, of course, we have what we call the elsewhere allophone, namely in all other contexts, if there is no other context-specific indication, then we'll pronounce this abstract phoneme T that consists just of the distinctive features as a fully fledged, voiceless, unaspirated, alveolar plosive. Now, if this idea of phonemes and allophones seems a little bit abstract to you, fear not, you're well familiar with this idea from real life. For example, when you watch superhero films, usually superheroes have some kind of alias relationship with themselves. Take Superman, for example. Superman is in his costume as Superman when he appears in the context of danger. Whenever someone is in danger, then we get Superman. But elsewhere, in all other contexts, when he works at the Daily Planet, when he is around his family in Smallville, then we get Clark Kent, but we never get the 2 in the same room. Nonetheless, these are the same person. So there is an abstract entity, one that we can perhaps describe as Kal-El from Krypton, that turns out in one of these 2 guises, depending on the context. And similarly to what we've just done before, when we can define this environment being in danger and being in the elsewhere environment, we can formulate a rule. We can say Clark Kent turns into Superman when someone is in danger. So Clark Kent and Superman in the terminology that we've introduced are in complementary distribution with one another. Where one appears, the other does not. That is exactly the same relationship that we have between the different allophones of a single phoneme in phonology. So if we look again at the diagram we had just now of the phoneme T in English, which has all these various realizations, aspirated T, affricated Ch, a tap or glottal stop, the or and the otherwise unaspirated T, then we can similarly see that these are in complementary distribution, where one of them occurs, the other does not. And by the environments that we have written below each of them, we in fact indicate what exactly these exclusive environments are in which each of them occurs. So let's have a closer look at the rules by which speakers can derive the right form in the right context. This is the actual part that features in a speaker's knowledge about the context-sensitive realization of a specific speech form, phonological rules. Phonological rules generally have the form of an A goes to a B in some context C. Now normally here A is a phoneme and B is some sort of allophonic or non-distinctive feature including specification, but that's not necessarily the case. We can also have rules that later on apply to things that other rules have already applied to, so it's not necessarily true that it's the first thing that is taken from a speaker's long-term memory that a rule applies to. So we can read a rule like this here, A arrow B slash C, as A is realized as B in the environment C. For example, T is realized as aspirated T in the context of the beginning of a syllable, here using the square bracket at the left-hand side to indicate the start of a unit, the start of a syllable, which is indicated by this little sigma here. And then we have this little space. This is saying where the sound occurs, where the context is for making exactly this change. And then that occurs before a vowel that has the feature plus stress. So T is realized as aspirated in the environment at the beginning of a syllable preceding a vowel that is plus stressed. The next realization of T that we had was, of course, affrication, and here we can say that T is realized as an affricate ch in the environment at the start of a syllable preceding the sound r. For glottaling or tapping, then on the other hand, we can say T is realized as, for example, a tap in the context between two vowels, that is, following a vowel and then preceding another vowel, the second vowel of which has the feature minus stress. This, in essence, captures exactly what was indicated on the phonemic diagram earlier on, namely the various contexts in which these forms occur. So let's try and employ these ideas of phonemes and allophones and rule-based derivations coming from an underlying abstract representation stored in the speaker's mind to a surface representation that is pronounceable by looking at another fascinating sound in English, the phoneme L, the lateral approximant. So this has several forms that can occur in English. The first one that we'll be looking at is what is sometimes called a dark L, a velarized version of L that occurs at the end of syllables. We find this in words such as file, fool, all, ball, feel, and fell. And you can hear that the sound is slightly different to the L that you find, for example, in words such as love and live. File, fool, all, ball, fell, feel. Now, in some accents, of course, also, this is realized as a labial velar approximant. For example, a typical feature of Cockney is that these words will be pronounced as file, fool, all, ball, fell, and feel. Another version of L that you'll often encounter in the wild is an actual voiceless version that occurs in consonant clusters, namely when it is preceded by a voiceless consonant. So we find us, for example, in words such as slide, flight, plow, cling, and discipline. And if you're not completely convinced whether this L is actually voiceless here, just do that old trick of holding your fingers on your larynx and saying those words. Say something like slide, and you will feel that the vibration only starts once you get into the vowel. Another version of this L occurs as velarized and dentalized before a voiceless interdental fricative th, so that we find in words such as wealth, health, filth, tilth, and stealth. And here the thing to do, if you're not quite sure about this, is to say these words and then just stop whilst you're pronouncing the L. So if you say stealth and you stop in stel, you will feel that the tip of your tongue is actually pressing against the back of your front teeth. So these are the main three variants of L that we encounter in the wild, plus of course the elsewhere form, the normal or sometimes also called clear L that we find everywhere else, that we find in words such as listen, lose, allow, aglow, and blend. So let's draw a diagram of the phonemes and allophones to get a clearer picture of the distribution of the sounds. So here we have on the top the phoneme L, the abstract version stored in a speaker's long-term memory in terms of the distinctive features necessary to pick out the sound. And then we have the individual versions. First of all here, our velarized or dark L, or for some speakers then the labial velar approximant version of this, which occurs at the end of a syllable, indicated here by a closing bracket indicating the end of a unit, and the unit is named with the syllable symbol, the little sigma, to say at the end of a syllable. And then next we have the voiceless version, which occurs after a voiceless consonant. So here we've written C for consonant, and then we've annotated that with minus voice to say the consonant must be voiceless. And if it follows that, then you get the voiceless version. Next, you get the dentalized, velarized version here, the little bridge indicating that it is dentalized, the wavy line indicating it's velarized, and that we find precisely before a single consonant in English, namely the voiceless interdental fricative th, so we've just written that. And then the normal L, the clear L that we find everywhere else, we just have labeled elsewhere because that is of course our elsewhere allophone. Now, in order for a speaker to get from the abstract form that they've stored, the underspecified form that they've stored in their long-term memory, to the surface form that is eventually realized with all these variants encoded, they need to know the rules of when to apply these changes. So let's write these rules. Start with the velarization. So we have L velarization, which we can write as L goes to, or L is realized as a velarized L in the context preceding the end of a syllable. Next, we have L devoicing. We call it devoicing because the elsewhere allophone is always voiced, so we're assuming that there is an introduction of a feature minus voice here. So L is realized as a voiceless L when it is preceded by a consonant that is minus voice. And then finally, we have the dentalization of L, and here we say that L is realized as a dental velarized L when it precedes the interdental fricative th. Now, the other question that we asked at the very beginning of this week was, what is it that speakers know about how the sounds of their language can be combined with one another? And that, of course, is the field of phonetics. Phonetics being the study of the combinatoric possibilities of phones or sounds. So you might remember that in the first lecture we've already gotten our first glimpse of phonotactics. We have looked and compared sp and ps in English and in Greek, and what we have found was that sp is legal at the start of words in English, but ps is not, so we can have words like spin, but a word like psin is ungrammatical, whilst in Greek both of these sequences are allowed at the start of words, so we can have both sp and ps, as in words like spanachi and psychologia. So that means that speakers must have knowledge of the set of constraints of how the sounds of their language can be combined. These we call phonotactic constraints. It turns out that syllables, which are very difficult actually to define in structural terms, but we have a very good intuitive notion of so far, play a really important role in characterizing the combinatorial possibilities in a language. So, for example, the sequence ft or ft in English is impossible syllable initially. So that includes the start of a word, of course, so we can't have words like phthalate. However, the sequence ft in and of itself is completely legal in English, provided the syllabification is correct. So if you look at a word like after, where the f belongs to the first syllable and the t belongs to the second syllable, after, then the sequence ft is completely fine. So the syllabification plays a crucial role in the phonotactics or in the combinatorial possibilities of sounds. And in actual fact, when you think about it, that is really useful for a speaker or for a listener, rather, who wants to figure out where the boundaries between words or between syllables are. Because now if they hear the sequence ft and they know that they're listening to someone speaking English, they know, oh, this must be the break of a syllable and quite possibly the break of a word here. Now, phonotactics is of course an endlessly fascinating and incredibly important subject, but we will have to leave it here for today. So let us summarize what we've seen today. We've seen that speech sounds consist of underspecified bundles of features. Specifically, speakers have knowledge of what features are important to make contrast in their language, what we've called distinctive features, and these are the features that are stored in the underspecified feature bundles in long-term memory. Sounds are grouped into natural classes based on the shared features that they have, and these natural classes are important to make generalizations about phonological patterns. For example, we have seen that voiceless stops in English are realized with aspiration at the start of a syllable, and this can be characterized as a generalization over a natural class. If we didn't have these natural classes, and if these natural classes weren't something that figured as a real entity in a speaker's mind, then they would be unable to make these generalizations, and it would just be as likely that we find a language where one of these sounds is aspirated, another is not, and to a third one something completely different happens perhaps. But in fact, in language after language after language, sounds that form natural classes behave alike, and we can make generalizations over these groups of sounds rather than over only individual sounds a lot of the time. Speakers know how individual phonemes are realized in a given context, so that is the knowledge that they need to get from these underspecified feature bundles that they've stored in long-term memory, the underlying representation, to a surface representation, something that can be pronounced and realized in a context. And finally, speakers seem to also have knowledge about the constraints that apply to how sounds can be combined, which is knowledge that is useful for them not only in constructing possible words in their language, but also in parsing the input and figuring out where the boundaries between, for example, different syllables and different words lie. So next week, we'll be looking at the field of morphology, which is of course one level up from phonology, now using forms of combined sounds that can minimally contrast meaning to form complex words.